Gonna go through this one. So I'm gonna get, ooh, that's an aggressive. I'm gonna get log base 10 of 2 plus x plus 1 log base 10 of 5 equals 2x plus 1 log base 10 of 3. Distribute. Log base 10 of 2 plus x log base 10 of 5 plus 1 log base 10 of 5 equals 2x log base 10 of 3 plus 1 log base 10 of 3. And then you have to get the x's together. And I was lazy, so I moved this over to there. I didn't make the x's to the left because I like having them more positive. Minus log base 10 of 3 equals 2x. You'll still get the same answer if you did the other one. Log base 10 of 3 minus x log base 10 of 5. Then take an x out. And remember I said with the log base 10s at the end you could actually drop them off and you could just put in log 2 plus log 5 minus log 3 divided by 2 log 3 log 5 because log base 10 is just the log button. And what does x equal? Does anyone get it?
It's like 2.05.
2.05?
Yeah, when you round it.
Okay. So that was one where I can ask you, it has that extra one, like I told you. I told you while we were doing this, and I'm telling you now. You have to be able to do that. Then the next one was the solving a log one that I said. And it is log base 3 of 2x minus 1 equals 2 minus log base 3. If I can get your brain to see log base 3 and log base 3 put me together, you will be in a much better boat than everyone else. Because that right there shows them on both sides, correct? But I know that I have to put them together. The only way I can put them together is if they are together. So I'm going to have to move one of them. I'm going to move the one that's with the 2 because I want it to come over here. So I'm going to add it over. So now I have log base 3 of 2x plus 1 plus log base 3 of x plus 1 equals 2. They're added. They have plus 1s in front. What if they had like a number in front of one of them? I would have to raise it up to the exponent, right? And then I would actually have to FOIL this one or this one. Like if there was like a 2 and I brought the 2 up here, I would have to go x plus 1 times x plus 1. You would have to FOIL them, right? You wouldn't write x squared plus 1. You'd write x squared plus 2x plus 1. You would write them out twice and FOIL them. Okay. So we have log base 3 of 2x plus 1 times x plus 1 equals 2. And what do I always do when I have a log and something beside it's a variable or the base?
Isn't 2x minus right? 2x plus. No, it's minus.
It's minus. You will convert to exponentials. So 3 to the 2 equals 2x minus 1, x plus 1. And you know what? Even if I had done the plus 1, you guys, I would catch my error. Because what am I going to do whenever it's a solving? I'm going to y1, y2, this out, and I'm going to get an answer. And then, I just did this to me. And then it won't match. And I'll be like, what did I do wrong? And I'll be like, oh, you didn't write. And remember I told you, cover up your work. Try again on a separate sheet of paper. So we have 9 equals 2x squared plus 2x minus 1x minus 1. Move it over. 2x squared plus x minus 10. What multiplies to give me negative 20 and adds to give me x? 5 and negative 4. So I'm going to get 2x squared minus 4x plus 5x minus 10. And whenever I solve a log, I have to check for extraneous roots. When I solve these out, I get x equals negative 5 halves and x equals 2. And remember, I always have to check them. So I take the negative 5 halves, which is negative 2.5, and I go up here and I go 2 times negative 2.5 is negative 5 minus 1 is negative 6. That's a problem. I can't have a negative there, right? So I circle it, and it's extraneous. Then I try the 2. Sometimes both are extraneous, sometimes neither are extraneous. You just have to check. Take the 2, plug it back. 2 times 2 is 4. Minus 1 is 3, so that's good. I have to keep checking. 2 plus 1 is 3. That's good. So this is good. Also, y1, y2 would tell me that I was right.
Do you have to make extraneous?
Yes. They will look for that.
You have to know how to spell it, right?
You have to make it sound extraneous, like not extraterrestrial. Okay. Then, number 3. Number 3 has done the most poorly.
I didn't think you guys
We have to write it as a single logarithm, so every single one of them has to be log base A. So I have 2 log base A of x. Pay attention because you will remember it. Of y plus 6. So what I often get as a multiple choice answer or a written response answer, if I give this or something like that, what I'll often get is people will remember to bring the 2 up. So remember to bring the 3 up. And then I get the answer, log base A of x squared over y cubed plus 6. Which is lovely. However, that's not a single log. That's a log with a number floating at the back. Which is just lovely this time of year, but not a single log. So, I go, oh crap, what can I do? Well, this is log base A, this is log base A. I need this to be log base A, or I can't put it together. It's just sitting there. Yeah?
On our test, can we bring in like scrap pieces of paper?
No, but I'll have scrap pieces of paper. I have all those lined. That little black, little pile of paper is lined.
Thank you.
Yeah. And then just make sure your paper gets stapled to the test. Okay. Because it's for help for you for later when you look. So we have log base A of x squared. Ooh, it moved back to normal. That's awesome. Just on its own. X squared. And then minus log base A of y cubed. Everyone's good with that. And then I need this to be log base, why did I, plus sign? Log base A of something. And that has to be 6. This has to be equivalent to that. I don't need to be log base A because that's the base. If it was log base 3, it would have to be base 3. If it was log base 7, it would have to be 7, right? If it's log base A, it has to be A. If it doesn't have a base, it has to be log base what? 10. We agree? So what can I put this to so that its answer would be 6? You guys know this. No, what could I put it to so that its answer would be 6? A to the what?
A to the 6.
Yes. I would make this be A to the 6. Because what's log base A to the A to the 6? 6. So what if it was log base 5? How would I get it to be a 6? 5 to the 6. So if it's log base nothing, what is the base? What should you always do when there's no base? Please. Put a 10 every single time. What would I have to do here? 10 to the 6. Right? Because when you make the same base the number aside, the exponent is the answer. Now I can put it together. So if you can get to that step right there, it's an easy question. If you can't get to that step, you're never getting the answer. It's really just that. So we're going to go log base A, x squared in the numerator, y cubed in the denominator, a6 in the numerator. Just stays. Right? Okay? It's not, but if you don't spot it or reason it, then you just sit there and stare at it and you're like, I don't know how that comes along. Little details. Okay. I don't know. 4. What if I give you log base 2 of log base 3 of log base 2 of 2x minus 1, close bracket, close bracket, close bracket, equals 1. Solve it. Could we not y1 this one? y2? If it was a multiple choice numeric response? Yes. If it's a written response, remember that as many logs are embedded is as many times as you have to convert it to exponential. Yeah. So how many logs are embedded here? 3. So how many times am I going to have to convert it? 3. So for the first one, I'm just going to remind you here, for the first one, treat this dashed part as something that's beside the log. So what's my first one going to be? 2 to the 1 equals the blue dotted area, right? 2 to the 1 equals this bad boy. And now I've converted once, so I'm on a good roll. But I have 3 embedded, so I need to convert 3 times. What I am not going over today, because I don't have time, is graphs of logs and exponentials. You need to know those. We've discussed it, right? How do you get an asymptote? How do you get domain range of exponentials and the logs? That's one. And the other thing I'm not going over are the 3 types of word problems. But I told you they'll be on. There's compound interest, doubling, tripling, half-life, appreciation, depreciation. So you're like, I wonder if they'll be on. There's no wondering. I've told you every single time. And you're like, but what if I'm not given the formula? You're not. And if you are, throw a party. Be excited. You know, cartwheel in your head or something. Be excited you have a formula there. If not, be prepared for not having a formula there. No. It would suck to try. It would really suck to try. Okay. Now, what I would do if it were me is I would memorize those formulas, and then when the test was handed to me, I would immediately write them down. That's what I would do if I were you and you were me. That's what I would do. So you're going to get 3 to the 2 equals what's beside the log now? Log base 2 of 2x minus 1. 3 squared is 9, so I'm going to do that first. And then I converted twice, so I have one more to go. 2 to the 9, which is a large number, equals 2x minus 1. What's 2 to the 9?
512.
512. Add 1. 511 equals 2x. Divide by 2.
Isn't it 513? It's 513.
Don't know what you're talking about, vultures. It's 513! Yeah. It's like attacking me. Just kidding. I would have had a really bad mark. I wouldn't have, though, because I would have checked this with y1, y2. And then I would have known I was wrong, cried a little, revamped, went to a separate sheet, tried again, probably wouldn't have made the same stupid error. Right? Collected myself and been like, you can do this. I believe in you. That's what I would say to myself. Okay, what do we get?
256.5.
256.5. Half of 13. It's an odd
Oh, you
number.
have to add the one that's there.
Yeah, like what I did. Okay, you'd still get 11.
Yeah.
Okay, now, just so you know, if you second trace 5, enter, 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 it doesn't matter how viciously hard you hit the enter button. And it says, not going to happen to you. The reason why is the answer is 256.5. Do you see that? If your X max is not bigger than that on your window, ain't finding it. So whatever your X value is, if you're checking, make sure your X max is bigger than that, and then go to town. Second trace 5, enter, enter, enter. But if you, no matter how hard you hit those enters because you're mad, and your X max is 10, it is not finding 256.5. If your X max is 100, still not finding 256.5. If your X max is 1,000,000 because you start getting like out of control, it might not be able to find it because your window's so freaking large. Okay? So we don't go like 1, 10, 100, bajillion. Just how many zeros can I press? Don't. It's bad. No. Okay, now I have one more. What if I give you logs? All logs. Logs, logs, so many logs.
No more.
We go over how to learn asymptotes.
Okay, this bad boy. Number 6.
So we solving that?
Exponentials are y equals horizontal based on the translation, vertical translation. Logs are vertical based on the horizontal translation. Logs, vertical. Yeah.
So exponentials are horizontal asymptotes.
So when exponentials have a horizontal, the only thing that's moving that bad boy is the vertical translation. And a log is vertical, and what's the only thing moving that bad boy? Horizontal translation. Now, the only thing that catches it too is the domain is x is greater than, unless there's a reflection, and then it would be less. Exponentials are greater than, unless there's reflection in the y. Yeah, x. Ooh, good one. You were right. I was going the wrong direction. I was showing it, but not saying the right thing. In the x, because then it'll be down here somewhere instead of up here somewhere. It'll be down here somewhere. Visualize. How do you do domain and range?
Look at the graph.
Exponential graphs do this. They're up here, correct?
Yeah.
Only thing that's moving this bad boy is vertical translation, correct?
Yeah.
Say the vertical translation is 3 down. Well, now it's here. So your range would be y is greater than -3 unless there's a reflection in the x, and then it would be bam, bam, down there.
You get that from the b value.
No.
Sure.
A, b to the x. This is all based, let's say there's a d. This here is my vertical translation, which gets me my asymptote. If this bad boy's negative, it's less than. If this bad boy's positive, it's greater. So this is what helps you with the range, because range is based on what? X's or y's? Y's. So it's based on the y's on this one. Okay? Logs go like this. Even though your calculator looks like it stops, the log keeps going. It has a range of YER and a domain of x is greater than the horizontal translation, or x is less than the horizontal translation if there is a bad boy negative. If this was your equation, it would be x is less than -3. All we care about is this for logs. If you're super stuck and they give you variables, they have to tell you what the variables are. So they have to say b is greater than 7, which they'd never do. They'd be like, b is greater than 1. And then you're like, oh, 5. And you plug in a 5, then you look at the graph, and you at least go that route. You know what I'm saying? Mm-hmm.
So if there's if negative, it's going to be x is less than?
Yes. If x is negative, because it's affecting the x's because it's domain, it's going to be less than. If this wasn't here, it'd be greater, because it's not reflected on the y. Can we solve this one?
But on a log graph, it's y.
On a log graph, it's YER. On an exponential, it's XER, because they're inverses of each other. And on an exponential, it's y is greater or less. And on a log, it's x is greater or less, because they're inverses of each other. I can remember like log, exponential graph, and a log, exponential, and a log, I could do my own little, like, I should have caused my own little exercise class. Exponential, and a log, exponential, and a log, What can move this? Reflection in the y. What can move this? Reflection in the x. See, Mitch is he just burned like 10 calories. The rest of you, sitting there watching.
You'll see me do that.
Okay, this log, you can do 2 ways. If they're all logs, I would myself do the shorter method, which I will put above here. We're running out of time. Why is it? Oh, okay, it moved eventually. All right, so if they're all logs, what I do is whatever logs are on the right, put together. Whatever logs are on the left, put together. This is what I do. Okay? So this side, base 7, base 7, base 7, it screams, put me together. So you can either move them all together and put them together. Or, because they're all logs, which is shorter if you just do this, you put the logs on the one side together, put the logs on the other side together, and watch. So we're going to get log base 7, and then here I would get x times x minus 1. And then on this side, I would get log base 7 of 4x, correct? Now, if I have logs on both sides, it's actually easier. Because if this is log base 7 of this, and this is log base 7 of this, what should they equal? Each other. So I would get x squared minus x equals 4x. X squared. Now when I don't have like a c value, I still just move everything over, and then we sit and stare for a while. But whenever we sit and stare for a while, 98% of the time, it's what? GCF. If you have left with nothing in your brains, it should be that and put me together at the end of this semester, at the very least. Take an x out, we're left with x minus 5, and we get x equals 0, and x equals 5, and then I check them. I put a 0 back into the question. Log base 7 is 0.
No.
It's done. You have to have a positive, so that baby's gone. Extraneous. Or I put a 5 back, I have a 5. Good. 5 minus 1, 4. Yep. 4 times 5, 20. Good.
The x value doesn't work. It has to be those
It can't be, equal to 0. Now, if you go to do the long method, because you're like, I don't like that, you can move, or you have an addiction to putting them together because I've pushed it so, strongly. You're going to move the 7 over, which is, wow, that's a thick marker. It's thick. Okay, 7 of x plus log base 7 of x minus 1 minus log base 7 of 4x equals 0, right? I can put them together. I can go log base 7, x minus 1, and then on the bottom I get 4x equals 0. And then what am I going to have to do now? Convert to? Yes.
exponential. But I have a question.
Yeah.
If, let's say you gave us a question like that and it was equal to 0, could we add along to the other side? And
Yes, as long as there's not a random number with it. Like if there's a +2 at the back or a +4. But you could turn those into the same log base. We just learned that, remember? So you could actually always make them all the same logs, technically. So you go 7 to the 0 equals x squared minus x over 4x. What's 7 to the 0? 1. Wow. I have work down there. 1 equals x squared minus x. And then people stare here for a while. What can I do next, and what do I have to do next? Multiply by 4x. Whenever you have a denominator, and she's gone, now we don't have fractions anymore. We have 4x equals x squared minus x. Now we're at the same spot as the other one, but it took us 800 years longer. Approximately 800 years longer. Same answer. X equals 0, can't happen. X equals 5. Good. Extraneous. She's like,